Assalamualaikum warahmatullahi wabarakatuh. My name is Hazman Aqeel 075531.
Hi, Assalamualaikum. My name is Mukriz bin Muhammad Ridwan and my matrix card 075379.
Hi, I'm Amirul Haqim bin Muhammad Nasani and my matrix number is 075519.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Izzat Hanif bin Tasmono. My matrix number is 075421.
Alright, so today we're gonna present about computer. How
digital computer works.
Yeah, how do digital computer works, and
Your point?
Okay, my point, I will start with how does computer think, binary system, and key component of computer circuit.
and for me, I'm gonna talk about definition of computer and about Moore's law.
And I will explain about how does computer transfer information, save instruction, and execute instructions.
And finally, I will talk about memory hierarchy and embedded systems.
Alright, so here we go.
Alright, I will start with how do computer think. Okay, in metaphor, we can say that computer is like a child who has very little knowledge about the world, but can receive and execute order brilliantly. The order can only be executed if the order is logic, specific, and accurate. Why did I say that this is the most accurate metaphor for how the computer think? Because when we start programming, every single detail must be taken. Why? Because a simple mistake can make the program cannot be read. Okay, right. For example, you're asking a child. We still in the metaphor. For example, you're asking a child to buy a can of soda. You need to tell him or her the direction, how far, the distance between the house and the store, the interaction between the child and the seller, and what if there's no soda, and way back from the store and the house. This is the best example because it's explain about the logic, specific and accurate. Alright, next we go to the binary system. Whether we like it or not, whether can only understand and receive order in the form of binary, which is 0 and 1. And my ask why must 0 and 1? Because binary digit is the smallest unit digit which hold whether the number has or can take a value or not. This is very important. Okay, this is the most important part in the computer to receive order. But maybe some of you will ask, we are programming in character with ABC. It's not 0 and 1. Yeah, that's correct. Because the program we use to insert the ABC or maybe character like 1, 2, like it's not 0 and 1. It's a converter. It's a converter. When you write system open line to search hello world, that's just a converter. When you write in Java, it will convert the hello world into the binary system 0 and 1 for the computer to execute it, to read it and to execute it. This thing apply to all the converter system, coding system, which like Java or C++, Arduino. Alright, that's all for binary system. Next, we go to the key component of computer circuit, or might I say, the organ of computer circuit. As the list here, there's integrated circuit, bus system, transistor, and central processing unit, or we might as well call it CPU. To be exact, CPU is not the PC one, the big frame. That's not CPU. CPU is a small chip, the motherboard of the computer. Might I say the CPU act as a brain where all the information, where all the system go in and out. Next is transistor. Transistor as a nerve. It's a nerve of way as a nerve for the information to flow. And the bus system is exactly like impulse, where the information move in and out from the CPU to the memory system. And for the integrated circuit, it's a complex organ of the computer circuit. Alright, next.
So I'm gonna talk about Moore's law. So first of all, what's Moore's law? Moore's law is the observation that the number of transistors in an integrated circuit IC doubles about every 2 years. The law was first described by Gordon E. Moore, the co-founder of Intel, in 1965. Okay. Moore's law applies that computers, machines, then run on computers, and computing power all become smaller, faster, and cheaper with time as transistors on integrated circuits become more efficient. Okay, the consequences of Moore's law. There's 4 that I put. First, the cost of computer logic and memory circuitry has fallen at a dramatic rate. The computer becomes smaller and is more convenient to use in a variety of environments, which like you got a laptop from, for example, there's the old computer that's called ENIAC. The ENIAC is larger, it's bigger than the room, from this room I think, and it costs more money on it and more time, and there's a lot of components that need to retake and so on. Okay, the third, reduction in power and cooling requirement, and fourth, fewer interchip connection. In the slide I put a graph of every year about the Moore's law will double twice. Like for example, this year it's only 4. Next year we'll double it until 8, and the next year until 16, 32, 64, and so on. So it will become more and more and more. It's not gonna lag, it's not gonna hang onto it. So the next, I'm gonna talk about definition of digital computer. A digital computer is a device that works with number represented by the digit 0 and 1. It's only 0 and 1. It is capable of solving problems by processing information in discrete form. Digital computer manipulate symbols, not necessarily digits, while analog computers manipulate electronic signals or other physical phenomena that act as models or analogs of various other phenomena. Alright, computer. What's a computer? A computer is a machine that can be programmed to carry out sequences of arithmetic or logical computation automatically. Modern digital electronic computers can perform generic sets of operations known as programs. These programs enable computers to perform a wide range of tasks. A computer system is a nominally complete computer that includes the hardware, operating system, main software, and peripheral equipment needed and used for full operation. This term may also refer to a group of computers that are linked and function together, such as computer network and computer cluster. Alright, there's 4 functions elements, and one of it is input-output equipment, I/O equipment. Second, main memory. Third, control unit. And fourth, arithmetic logic unit.
Alright, so how does a digital computer transfer, save, and execute instructions? Alright, so us as the user will give them instructions. Then, the computer that receive instruction from the input devices or external devices such as keyboard or mice. Then, the instructions will then be transferred into the computer's memory or RAM using system bus. I will explain about system bus later on in the video. And then, these instructions that are stored inside the computer's memory are given a unique address. Okay, so just remember that the instructions received from us from the input devices are transferred into the computer's memory using system bus, and the instructions inside the computer's memory will be given a unique address. Alright, so next, how does instructions get executed? So there's this cycle that consists of 3 operations, which is fetch, decode, and execute. Alright, so these 3 operations are used to execute our instructions. Okay, so fetch. The computer CPU will fetch instructions from the memory using the addresses. Alright, so I already talked about the instructions stored inside the memory will be given an address, right? So the CPU will fetch those instructions using the addresses. Okay, so next is decode. The fetch instructions are decoded to determine what operations are needed. Okay, and then finally execute. The CPU will execute the decoded instructions. Okay, so fetch. CPU fetch instructions from the memory, then it will be decoded into to determine what operations are needed, and then finally it will be executed, which means that the CPU will execute the decoded instructions. Okay, so let's look at this example. Us as the user give the computer an instruction to print a poster, okay, and then the instructions will then be transferred into the computer's memory or RAM, and they will be assigned an address. Next, the CPU will fetch the instructions from the computer's memory using the address to be decoded. Okay, then the CPU will execute the decoded instructions and then send to the output device, which in this case is the printer. Finally, the printer will print out the poster. Alright, so next is the bus interconnection. Okay, so what is bus interconnection? So there's a very long explanation about bus interconnection, but it's okay, I will simplify it for you. So generally, bus interconnection means that the transferring of data between components within the computer or between multiple computers, and it serves as a pathway to transfer information using signals. Okay, so simply it means that bus interconnection means the communication between different parts of a computer system. Okay, so the information gets transferred using signals, which in this case it will use binary zeros and ones and transmitted in the bus lines. And then the system bus. So system bus consists of data bus, control bus, and address bus. Okay, so system bus, it is a combination of data bus, control bus, and address bus. Okay, data bus, what does it mean? Data bus is the carrying of data between 3 components, which is CPU, memory, and I/O module. Control bus, they will carry control signals that coordinate activities of various components. And address bus, it transmits memory addresses and specifies the location in the memory or computer's memory. Okay, let's look at this diagram. We have 3 components, which is the CPU, memory, and input and output, and they are all connected using system bus, control bus, address bus, and data bus. Okay, get it? Next, remember this example I gave you? Alright, so now I will relate this example using the system bus, and I will break down the sentences into the bus types. Alright, so first, we give the computer an instruction to print a poster. Okay, using data bus, the instructions are transferred into the computer's memory and assigned an address. Next, using address bus, the CPU will fetch the instructions by the address to be decoded. Then finally, it will use control bus to decode instructions sent to the output devices, which in this case is the printer. Alright, and that's it. Thank you.
Alright, finally it's my turn to talk about memory hierarchy. What is memory hierarchy? According to Geeks for Geeks, in the computer system design, memory hierarchy is an enhancement to organize the memory such that it can minimize the access time. Memory hierarchy is one of the most required things in computer memory as it helps in optimizing the memory available in the computer. Design constraints on a computer's memory is summed up by three questions: how much, how fast, and how expensive. The memory must be able to keep up with the processor. As the processor is executing instructions, we would not want it to have to pause waiting for instructions. The final question must also be considered. So for a practical system, the cost of memory must be reasonable in relationship to other components. There is a trade-off among capacity, how much, access time, how fast, and cost, how expensive. It is faster access time, greater cost per bit. Greater capacity, smaller cost per bit, and greater capacity, slower access time. The dilemma facing the designer here is clear. The designer would like to use memory technologies that provide larger capacity memories. However, to meet performance requirements, the designer needs to use expensive, relatively lower capacity memories with short access times. So as a solution, they employ a memory hierarchy. So in memory hierarchy, the decreasing cost per bit, increasing capacity, increasing access time, and decreasing frequency of access of the memory by the processor. So here we can look the pyramid of memory hierarchy. So here we can see CPU register on the top and magnetic tape on the bottom. So the level goes down, the access time is increasing and capacity also increasing. So here we can look relative cost size and speed characteristic across the memory hierarchy. So here we can see main memory at the middle as there are main memory. So next I will talk about embedded system. Embedded system refers to the use of electronics and software within a product as opposed to a general purpose computer such as a laptop or desktop. Billions of computers produced each year are embedded with a larger device, and today many devices that use electric power also have an embedded computing systems. So here is possible organization of an embedded systems. The processor in embedded system are connected with human interface. They are connected to analog to digital conversion and digital to analog conversion. So they are also connected with diagnostic port, memory, and custom logic. So in embedded system, they have Internet of Things, as known as IoT. IoT refers to the expanding interconnection of smart devices ranging from appliances to tiny sensors, primarily driven by deeply embedded devices such as high-resolution cameras and video security cameras. It is a fourth generation that is usually thought of as the IoT, and it is marked by the use of billions of embedded devices. So as connecting to the IoT, they also have deeply embedded systems. Deeply embedded system is a subset of embedded system and has a processor whose behavior is difficult to observe both by the programmer and the user. The deeply embedded systems use a microcontroller rather than a microprocessor. They also has no interaction with a user and typically have extreme resource constraints in terms of memory, processor size, time, and power consumption. So here we can look a figure of Internet of Things from peripheral hardware, sensors and actuators to embedded systems. They can connect straight to internet, or they connect to local connectivity or local network as such LAN, WAN, MAN, and yeah. So from the embedded system, they connect to internet, so they can connect to other devices. That is Internet of Things. So that's all from me. Thank you.